So today what we're going to be doing is factoring using a different technique when we have an a value of 1 and our c is positive, given the form ax squared plus bx plus c. So we're looking at a quadratic in standard form. Here a times c equals c. So the easiest way to factor this is to list the composite factors of c, which in this case is going to be an 18, a 4, a 5, 56, whatever the last number is, the number without an x, until we find they make a sum of b. Remember, we're undoing the FOILing process, so we want to find two numbers that multiply together to give me b, but combine together, multiply together to give me c, but combine together to give me b. So we're looking at both operations here. So let's go ahead and get started. If we're looking at 18, we're going to list our list of composite factors, which is via the rainbow method. If you remember, we did the rainbow method where it was horizontal. This time we're going to do it with a vertical list. We're going to say, hey, I can divide 18 by 1. So I have at minimum 1 and 18. And then we go up the list starting from 1. Can I divide it by 2? Yes, I could divide it by 2 and I'll get 9. Could I divide it by 3? Yes, I could get 3 and 6. Could I divide it by 4? No. 5? No. And then now we're at 6. We've completed the loop or we've completed the rainbow, whichever method you want to describe. There's no other whole number factors other than the numbers we already have listed, because we could keep going up and we wouldn't hit another one until 9 and we wouldn't hit another one until 18. So that's it. And the reason why we're looking for a sum of b is because this is going to be a positive number. When I multiply these two things together, I need to get a positive 18, which means they either both need to be positive or they both need to be negative. Either way, when I add two positives, I'm adding their values together. Or if I subtract two negatives, I'm adding their values together. If I have a positive positive or a negative negative, I'm combining them. So 1 and 18 is going to combine to 19, 2 and 9 is going to combine to an 11, and 3 and 6 is going to combine into a 9. Now, what we want to do is we want to take some combination that multiplies to 18, so all of these fit, but that sum together to a 9. And we see the fact that it is going to be the last term right there. So the 3 and the 6 get me the 9. So what we're going to do is we're going to split that 9 into a 3 and a 6, or a 3x and a 6x. So when we look at this, I have two different options. I know that sum means the same sign. So option 1 would be, if they're the same sign, I could have a, let's see, for number 1, we could have a positive 3 and a positive 6. Multiply together, they'll give me 18. So multiply, they give me an 18. But when I combine, they would give me a positive 9. The other option, that when I multiply to give me a positive 18, would be a negative 3 and a negative 6. They'll multiply to give me an 18. But when I sum these together, they'll give me a negative 9. So I'm going to ask myself, what is my b term? It's positive 9, so therefore I'm going to stick with a positive 3x and a positive 6x. Set that right there. So I have a positive 3x and a positive 6x. Now I'm not actually going to do anything about the x squared term. I'm going to keep it. I'm not going to do anything about the 18 term. I'm going to keep it. But what this allows me to do is this allows me to do what we've done in a prior video where we've factored by grouping. So let's go ahead and let's group the first two terms. Now remember, we're only looking at these two terms and saying, what do these have in common? What's their greatest common factor? In this case, it's an x. After I factor out the x, I divided out 1x, so I have 1x left. I divided out the x, so I have a 3. Then, secondarily, I'm going to look at my next two factors. Now, in this case, I can divide both of these by 6, which means that if I factor out that positive 6, we'll have 6 divided by 6 is 1, so that's just an x. 18 divided by 6 is 3. So we have that. And then lo and behold, we notice that the remainder for both our terms is the same, so I can factor that out a third time and get x plus 3 and x plus 6. And boom, we undid distribution with a trinomial. So let's try it again, but instead of having a positive b, this time let's have a negative b. So same process goes along. I'm going to list my factors of c. In this case, I only have one set of factors, 1 and 5. 2 doesn't work, 3 doesn't work, 4 doesn't work, and I've completed the loop or completed the rainbow. No other whole number factors exist. We know that when we multiply these things together, I need a positive, which means I'm going to sum them because they're going to be the same sign. 1 and 5, very luckily, make 6. And so just like I was looking for this 9 earlier, I am now looking for a 6, which in this case, as we said, very luckily, it's the only set of factors. So I'm going to split this into a 1y and a 5y. Now again, we know sum means same, so for number 3, we know the fact that I have the option of either plus 1, plus 5, or minus 1, minus 5. If I multiply these two together, I get a positive 5, so that's good. If I multiply these two together, I get a positive 5, so that's good. But if I sum these together, so if I combine them, I'll get a positive 6. And if I sum these together, I'll get a negative 6. And that's what I'm looking for. So I'm going to have a negative 1 and a negative 5. And I'm going to keep everything else. I'm going to keep the y squared, and I'm going to keep the plus 5. And I'm going to factor both of these using their GCFs. Which means that if I look at this, I only see a y. So I'm going to put my y down there. I'm going to have a y minus 1 after I remove one y from each of the terms. And now, because that y is positive, that brings us to the other thing that we've mentioned prior, is if I ever see a leading negative, I know whatever my GCF is, in this case a 5, I'm going to factor out the negative, so that way my remainder is always positive. It prevents me from having to do this step twice and factor out a negative when I'm done. So if I factor out a negative 5, what we're left with is we're left with a negative 5 divided by negative 5. That's going to be a y. 5 divided by negative 5 is a negative 1. This allows us to see that our remainder is a y minus 1 both times, or y minus 1, secondarily, y minus 5. Perfect. Remember, if you're ever unsure, one of the things that you can do is you can actually FOIL these out just to check your work. So y minus 1, y minus 5. We know with y minus y, that gives us y squared, minus 5y, minus 1y, plus 5. So we see the fact that we're going to be combining these, which is why we check, and when we FOILed and we did the last term, we multiplied them. So we wanted to check both these, and this is where that comes from, is that first step of distribution. And this leads us to a y squared minus 6y plus 5, which was our starting problem, so we know we did that correctly. Let's go ahead and let's try a few more. And what I want you to try is I want you to try these two. See if you can't come up with a list of factors that combine together according to the sign to make that b term. Give it a shot on your own. Unpause it when you're done and see how you did. Okay. So at this point, 16 is a little larger of a number. It's going to have a larger set of factors, but it's no different. I can divide 16 by 1. I can divide it by 2. And I can divide it by 4. And because 4 is in itself the end of the loop, I stop right there. I'm looking at the sign on my C. I know it's a positive, which means they're going to be the same signs, so I'm going to combine them. I have 17, 10, and 8. We know the fact that we're looking for a 10. It's going to be this middle term. So I'll have a 2t and an 8t. And I know the only way that they're both going to give me a positive is if they're both positive, but in case we didn't know that, we could always double check and try out both versions. I could try a positive 2 and a positive 8, and a negative 2 and a negative 8. So if I multiply them together, I'll get a positive 16, I'll get a positive 16, so they both check out. And if I combine them, I'll get a positive 10 and a negative 10. We're looking for a positive 10, so I'm looking for this. Now, you might also be asking, well, why didn't I check the different signs? I could have said, well, what about a positive 2 and a negative 8? Or a negative 2 and a positive 8? But when I multiply these together, I get a negative 16, which is not what I'm looking for. So I automatically know that different signs isn't going to work, which is why we're not looking for the difference. But let's keep moving. So we said that the positive 2 and the positive 8 were what we were looking for. We're going to keep the t squared, and we're going to keep the plus 16. We're going to factor out 2 GCFs. Over here, there's a GCF of t. Over here is a GCF of 8. So if I have a t and an 8, I'm going to figure out what is the remainder. Well, if I divide out the t, I'll have a t. If I divide out this only t, I'll have a 2. If I divide out 8, I'll have a t. And if I divide out 8, I'll have a 2. Which leads me to see the fact that I have a t minus 2 and a t plus 8. T minus 2, that's a t plus 2. There we go. And again, if we were unsure, we could FOIL this out, but we know what's going on. It's not a y. Looking for t plus 2, t plus 8, t squared plus 8t plus 2t plus 16, t squared plus 10t plus 16. That is what we started with, so we know we did it correctly. There we go. And if you tried the last one, this is probably the biggest list. I can divide it by 1, I can divide it by 2, I can divide it by 3, I can divide it by 4, I can divide it by 5, and I can divide it by 6. 7 doesn't work, 8 doesn't work, 9 doesn't work, which means we've completed the loop or we've completed the rainbow. We know that we're looking for a positive 60, which means I'm combining them. So same signs. 61, 32, 23, 19, 17, 16. Boom. We see the fact that we have our 17 right there. Cool. And again, we know that they're going to be the same signs. So it's either going to be a positive 5 and a positive 12 or a negative 5 and a negative 12. We're not really going to check the different signs, because I know that when I multiply them together, I'll get a negative 60, which is not what we want. The only numbers that we're considering are when we multiply them together, I get a sum sign, so a positive. So positive 60 and a positive 60. Those both work, and if I combine them, I will get a positive 17 and a negative 17. I'm looking for the negative 17, so I have a negative 5 and a negative 12. I'm going to keep the h squared, and I'm going to keep the 60, so that when we factor these, I'm going to factor out an h. Here I have a leading negative, so I'm going to factor out a negative 12. Let's see, if I factor out the h, I have an h minus 5. And if I factor out the 12, it's going to change those signs. So h minus 60 divided by 12 is 5. And lo and behold, that works. And so one of the questions you might have is, well, what happens if you pick the wrong set of factors? Is there something that gives it away? And kind of yes and no. The only thing that gives it away is you're going to have to check your work for that. So let's say inadvertently we picked something different, something that when we combine them don't actually give us a 17. Let's say we misadded that and we thought 4 and 15 give us a 17. So we split our function into h squared with a minus 4h minus 15h plus 60. So let's say we picked the wrong factor and we try and work this. Well, when we go to factor this, I'm going to pull out my h and my negative 15. When I pull out the h, I'll have an h minus 4. And here I'll have an h minus 4. And it looks like it works, but let's notice something. So you'd say, okay, well, I got an answer here, and it's not the answer I got. But how do we check our work? How do we make sure that we did in fact factor it correctly? Well, we redistribute it. So I would say h minus 4, h minus 15. Distribute, get an h squared minus 15h minus 4h plus 60. Right here, h squared minus 19h plus 60, is that what we started with? No. Which means that this is not correct. Now, chances are if you misfactor this here and misadd it and say, well, 4 and 15 make 17, you're probably going to do that again, but chances, you might want to take a shot at it. Go ahead and FOIL it if you're unsure or if you're just basically not confident in the process. But we can see the process doesn't work too terribly bad. Which leads us to our last final question. What will the signs be for each binomial constant for each expression below? Well, what we know here is that the signs are going to be the same, and I need to get a positive number when I combine them. So it's the only two ways that I can add two numbers together and get a positive if they're both the same sign. Well, they're both going to be positive. Likewise here, they're going to be the same sign, but I need to get a negative, which would mean that they both have to be a negative. Because when I multiply positive and positive, I get a positive, but I add and get a positive. Here, when I multiply a negative and negative, I get my positive, but when I add them, I'll get a negative. Same here. Same sign, they both have to be positive. Same sign, they both have to be negative. And so are the signs always positive when C is positive? No. How do the signs relate to C? So when C is positive, the signs are the same. Either negative, negative, or positive, positive. Doesn't matter which one. And there you go. Okay, so what we're looking at right now is a continuation of one of our previous videos where we factored a quadratic in standard form where the last term was positive. However, in this video, what we're going to look at is when that last term is negative. So the idea is that just like before, when a times c is still equal to c, we're just looking at factors of this c term right here. So we're just looking at factors of negative 21. But we know the fact that when we unfoil this, or when we undistribute this, the two numbers have to multiply to give me a negative, which means they're going to be different signs. So our first clue is going to be if I see a negative number at the end, I know I'm not going to be adding the numbers like we previously done. I'm going to be subtracting the two from each other. Now, some of you might say, like, well, what two do I need to subtract from? Well, and we always take the big minus the small. And we'll assign signs here in a second. But let's go through. Let's list our factors of 21. So I can divide 21 by 1, get 1 and 21. Can't divide it by 2. I can divide it by 3, and I'll get 3 and 7. 4 doesn't work, 5 doesn't work, 6 doesn't work, and now I'm back at 7. So I've completed the loop, or I've completed the rainbow, which means that I'm looking at either 1 and 21 or 3 and 7. Because I'm taking the difference, I'm going to take the big number minus the smaller number. 21 minus 1, or the difference between 1 and 21, is 20. Big minus small, 7 minus 3, or the difference between 3 and 7 is 4. And I'm going to ask, what am I looking for? I'm looking for a positive 4, which means I'm going to be using the 3 and the 7. So I'm splitting that 4x into a 3x and a 7x. Now, here's where what we've done prior is we wanted to check the signs on that. And we said, okay, so for number 1, we either had a 3 and a 7 one of two ways. They were either both positive or both negative. But let's check this out. A positive 3 and a positive 7 give me a positive 21. A negative 3 and a negative 7 also give me a positive 21. Is that what we want when we multiply these together? No, we want a negative 21. So now automatically, we can't sum them. I can't have the same signs. I'm going to have to give them different signs. So if I have a positive 3, I must have a negative 7, because that's the only way they'll multiply to give me a negative 21. Or I could flip it and say positive or negative 3 and positive 7. That'll still give me a negative 21. Let's combine them. Now I need to combine these to get a 4. So 3 minus 7 is going to give me a negative 4. Negative 3 plus 7 is going to give me a positive 4. We wanted a positive 4, so we're going to use a negative 3 and a positive 7. Awesome. And so we're going to keep the other terms. I'm going to keep the x squared, and I'm going to keep the negative 21, and I'm going to factor this. I'm going to factor the GCF out of both sides. The GCF of these two terms is going to be an x, which is going to leave me with, if I divide out that x squared divided by x is 1x. Negative 3x divided by x, well, that removes it, so I'm just left with the negative 3. Over here, what I have is I have a GCF of 7 plus 7. And if I divide both these terms by 7, I'm left with an x and a minus 3. Which when I check both of these, I notice that indeed they both have an x minus 3, and they both also have a leftover x plus 7. And there's our answer. And now the big thing with this is if you're unsure, the easiest way to check your work is you think that's your answer, so let's go ahead and let's FOIL this and see if we are correct. X minus 3, x plus 7, x squared, plus 7x, minus 3x, minus 21. Combine my terms. Is that what we started with? Yes, that is what we started with. So our answers are correct. Now, if you inadvertently picked a different answer, you'll still get, if you pick the wrong set of factors, you'll still get to an answer, but when you recheck it, it won't be your original problem, which will clue you in that you did something wrong there. But if when you FOIL it, you get your original problem, you know that you inversed the process correctly. So let's do one more of those. So what we notice is the fact that our 54 is a negative, so these are going to have different signs. So when I list my list of factors, which are 154, divide that by 2, 27. You can divide it by 3, so 3 fits in 5 once. 24 8 times, so 3 and 18. Does 4 work? No. Does 5 work? No. 6 and 9, 7 and 8 don't work. So we've completed the loop or we've completed the rainbow, however you want to look at that. And if I take the difference difference between that is 53, or you could look at it as what is big minus small. Big minus small is 25, 15, and 3. And we are looking for a 3, which is going to be our last terms. And now we know, just like before, they can't be the same signs. They're going to have to be different signs. So it's either going to have to be a positive 6 and a negative 9, or a negative 6 and a positive 9. That's the only way that when we multiply them together, that we're going to get a negative 54. We could try a positive and a positive, negative, negative, but it wouldn't work because, again, they need to be different signs. But when I combine them, when I add the two together, that's going to give me a negative 3, and that's going to give me a positive 3. And we are looking for the former. Perfect. So we know that when we split this 3 up into two terms, we'll have a positive 6 and a negative 9. We're going to keep the y squared. We're going to keep the negative 54. So let's factor out the GCF of both of these. This is a y. This is a negative 9. If I divide out the y, I'll have a y plus 6. That'll change my signs. Y positive 6. So I have my y plus 6 and my y minus 9. Perfect. And again, if you really wanted to, you could check your work and see how you did on that. But if we followed it out, we would get, let's see, y squared plus 6y minus 9y, which would be minus 3y. Then 6 times negative 9 would be negative 54. So we know that that checks out. What I want you to try is I want you to try the next two. Give the next two a shot. See how well you did. Unpause the video when you're done and see if you got it. Okay, so assuming that you've taken a shot at this, we know both of these have negative numbers on the end, which means we're taking the difference of our list of factors. And so for both of these questions, I'm going to see how many things I can divide 48 by. I can divide it by 1, I can divide it by 2, I can divide it by 3. Let's see, that'll fit in 1, and then 18, 16. I can divide it by 4, 5. I can divide it by 6, and that's it. I've completed the loop. 80 is a similarly big list. I can divide it by 1, I can divide it by 2, I can divide it by 4, I can divide it by 5, I can divide it by 8, and that completes the loop. In both of these, I'm taking the difference of the numbers. So big minus small is 47, 22, 13, 8, and 2. The difference of these over here is going to be 79, 38, 16, 11, and 2. For either one, we're looking for a difference that gives us our middle terms. So in this one, I'm trying to find a difference of 2. It's going to be my last set. For this one, I'm trying to find a difference of 11, which is going to be almost my last set. So now I'm splitting this 2 into a 6t and an 8t. For this one, I'm going to be splitting that h into a 5h and a 16h. So for number 5, I'm checking is 6 minus 8 or is negative 6 plus 8 going to give me the number that I want? They both give me negative 54. Ignore that. They both give me negative 48. But when I combine them, this gives me a negative 2, this gives me a positive 2. We're looking for a negative 2. Down here, I do the same thing. I say, I don't know if I have a positive 5 or a negative 5. If it's positive, that must mean it's a negative 16. If it's negative, that must mean it's a positive 16. They both multiply together to give me a negative 80. But when I combine them, they give me two different numbers. This gives me a negative 11. This gives me a positive 11. And we're looking for a positive 11. So for this one, I'll have a positive 6 and a negative 8. For this one, I'll have a negative 5 and a positive 16. In both cases, I'm going to keep that first term, that last term. I'm going to keep the first term and the last term. Cool. And then we go ahead and we factor this using the factoring by grouping. Pull out a t, pull out a negative 8. T plus 6. That negative 8 is because I had a leading negative, and that's going to change the signs. So t plus 6. So I have a t plus 6 and a t minus 8. Perfect. This one I do a similar process. I don't have a leading negative though, so I can just pull out a positive 16. H minus 5, H minus 5. And yeah, they both have an H minus 5 in there. And H plus 16 is the leftovers. Perfect. So how'd you do? Awesome. So that leads us to our last question. Our last question is, can you tell which factor will get you the sign? As opposed to doing what we've been doing where we write out plus 5 minus 16 or minus 5 plus 16, is there a way that without writing anything down that we can just look at it and tell? So if my two numbers, 5 and 3, multiply to give me negative 15 and sum to give me 2, well, that would mean that out of plus 5 minus 3 or minus 5 plus 3, the only way I can get a positive 2 is if the 5 is positive and the 3 is negative. So it looks like the bigger one got my B sign. Same thing right here. I could either do a positive 5 minus 3 or negative 5 plus 3. Different signs. What I'm going to have to do is the 5 is negative and the 3 is positive. So again, it seems like we have something of a pattern here. Positive, my bigger one got it. Negative, my bigger one got it. Let's take a look at this. So they add up, or they multiply to give me a negative, so it's either 21 minus 2 or negative 21 plus 2. In this case, that's going to be positive, negative. Again, do you notice which number, the bigger or the smaller, is going to get that sign? It's always the bigger one. Always the bigger one. I bet you the 7 is going to be negative and the 6 is going to be positive. So I could either do plus 7 or minus 7, minus 6 or plus 6. And yep, 7 is negative, 6 is positive. So the shortcut, without having to think, is the larger of the two keeps the sign of B, or the B term, or if you want to shorten that up, the bigger gets the B. Perfect. There you go. Okay, so today what we're doing is kind of a quasi-third technique. It's similar to what we've done previously, except for the only thing different is that our A is not going to be equal to 1. We notice that each one of our x squared, y squared, or each one of our squared terms is going to have a coefficient instead of just being by itself. And so now we run into the unique scenario where A times C is not just what C is. But that doesn't really change our overall process. This means the fact that we're going to have to multiply A times C before we list our composite factors. And just to show you, that, let's say we ignore this. And one of the things that a lot of students do is they will quite literally ignore this. And they'll say, okay, I see that 4x squared. I don't know what to do with it. I'm just going to deal with the 15. So if for number 1, let's say we don't want to do this. Let's say with that 4x squared plus 16x plus 15, I'm only looking at the 15. And I'm like, okay, I want to do that, which means I'm listing factors of 15 that sum. 1 and 15, 3 and 5. That's it. Well, 1 and 15 sum to 16, 3 and 5 sum to 8. Lo and behold, you found your 1 and 15. We know that because they both get the same sign, you're going to split that into a 4x squared plus 1x plus 15x plus 15. And you feel pretty good about this. You're like, okay, I'm going to group x 15. And then you say, okay, that's a 4x plus 1. And this is an x plus 1. And we run into our first problem, is that these are not the same. So we cannot factor. And what many of you might do is you might run to the next one. You say, well, let's try 3 and 5, and you'd run into the same problem. Your remainders would not be equal, so we cannot factor any further. That's because we're not quite doing the right process. We've forgotten to include the 4. But no big deal. That's what we're here for. So let's go ahead and let's try this different. Let's take that 4 and multiply it by the 15. And what do we get? We get a positive 60. A very different number than what we had prior. We know the positive 60 means that we are going to be taking the sum of the numbers. So I'm going to list all my factors of 60, which are kind of numerous. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Had to kind of squeeze them all in there. And we're going to be summing them up. We're going to be adding them together. So 61, 32, 23, 19, 17, and 16. And lo and behold, what we're trying to find is a 16, which is going to be this last number on the list. So I'm going to split that 16x into a 6x and a 10x. We're going to leave the 4x squared, and we're going to leave the 15. And so now when we factor this by grouping, the process starts out and works pretty much the same, except for we're going to get a 2x right here and a 5. So I factor out the 2x and the 5. What we're left with is a 2x plus 3 and a 2x plus 3. This works much better. So I have a 2x plus 3 times a 2x plus 5. Boom. And there we go. Awesome. And if we check that, we could actually check our work and say, okay, well, what is that if I FOIL that out? Let's continue on our little sheet over here. So if I said 2x plus 3 times 2x plus 5, see, 2x times 2x is 4x squared. 2x times 5 is 10x. 3 times 2x is 6x. 3 times 5 is 15. Combine those middle two terms. And if I check that against my original problem, they are the same, so we factor that correctly. So we see that, albeit prior, when we had that leading term just be the value of 1, we were doing this method, but we weren't aware that we were doing it, because our C term times 1 was our C term. So we didn't need to multiply them because we were without doing it. The 1 didn't actually change what was going on out here. So let's do one more of those. So we're going to take our first term and our last term, and we're going to multiply them together. That's going to get me a negative 80 And I know because it's a negative, I'm not going to be adding them. I'm going to be taking the difference. And now I'm going to list my factors of 80, which again are rather numerous. I can divide it by 1. I can divide it by 2. I can divide it by 4. I can divide it by 5. And I can divide it by 8. And because I'm looking for the difference between 1 and 80 is 79. Or you could say big minus small. 38, 16, 11, and 2. And we're looking for, in this case, an 11, which is going to be right there. So we're going to split that into a 5 and a 16y. We know because these are going to have different signs, we've also learned that the bigger gets the b, so 16 is going to have the negative. But again, they have different signs, so I know 5 must have the positive. Leave everything else on there. Leave the 4y squared, leave the minus 20, so that when I factor this, see that's a y, and because that's a leading negative, I pull out a negative GCF. (4y plus 5), and this is a 4y plus 5. Perfect. We have a 4y plus 5 and a y minus 4. Okay, so what I want you to try is I want you to try the next two and see how well you do. Unpause the video when you're done and check your work. Okay, so assuming that you've paused the video and you've given this a shot, let's take a look and see how well we did. Okay. So this one's not too bad. 3 times 2 is going to give us a positive 6. So our list is going to be rather small. You know that positive 6 means sum, so we're going to be adding them together. And there's only 2 sets of factors, 1 and 6, and then 2 and 3. We know if we sum 1 and 6, that's 7. This adds to 5, and we're looking for 5. Sum means same, so they're both positive. So I have a positive 2t and a positive 3t. We keep the 3t squared and the positive 2. As we work through it, pull out our GCF of t. And with this one, you might have faltered because there's no GCF. So I don't have anything to pull out. So I'm just going to pull out nothing, in which case it's going to be a 1, because if I divide everything by 1, nothing changes. So t and 1. Divide this, I'll get a 3t plus 2. And I'll get the same thing that I had over here, which is a 3t plus 2. And so we notice that it might be tempting to always want to pull out something, but sometimes not pulling out anything at all is the best solution. Ended up working out in our favor. And that's how we got here. Perfect. And if you tried the next one, similar process. We took a 12 and a 6, multiplied them together. That gives us a positive 72. Positive means sum, so we're dealing with the same signs, whatever they may be. We list our factors of 72, which start with 1, 2, 3, see that fits in 24, 4, 5 doesn't work, 6, 7 doesn't work, 8. And then at that, we've completed the loop. We add them all together, 73, 38, 27, 22, 18, and 17. And we're looking for a 22. So a rather big list here. So I'm going to split that 22 into a, let's see, they're both the same sign, and I have to have a negative, so it's going to be a negative 4w minus 18w. I'm not going to touch the 12w squared, and I'm not going to touch the positive 6. I'm going to factor out the GCF. In this case, it is going to be a 4w And over here, because of the leading negative, a negative 6. So 4w minus 6. So 12 divided by 4 is 3 minus 1. So 3 minus 1. Hey, cool. We got a 3w minus 1 and a 4w minus 6. And there we go. But wait, some of you might have gotten a slightly different answer. Some of you might have listed the 18w first, and when you factored it, you would have gotten something that looked like this. And so tell me, why, we discussed this previously, it shouldn't matter which order we put these things in. Why is it that when we put the 18w first instead of second, we get a completely different answer? It's not because the math is wrong. If you check this, everything works out. Why are our answers different? So why did one I get a 3w minus 1 and a 4w minus 6? One I got a 6w minus 2 and a 2w minus 3. What's going on? Well, some of you might have taken note that what you see going on here is that it looks like this one is double. And also in reverse, this one is double. So another way that we might look at that is that it looks like one doubled and one halved and one halved and one doubled. It's almost as though there's a 2 that's kind of floating out off to the side. So if we take that one step further, why don't we pull out that doubling factor and say, hey, let's move that off over here. And so if I got rid of the double that moved into this one, that would mean I'd have a 3w minus 1. And if I got rid of the double that moved over here, if it was on the other side, I would have a 2w minus 3. And I have option 1 where I could put it in here and get a 6w minus 2 and a 2w minus 3. Or I could put it in the second term and get a 3w minus 1 unaffected, and then this would be doubled. So it looks like there's a factor floating around in there, and I wonder if there's a way we could handle that. And so we're actually going to handle that in a future video, but we want to leave off on this last little piece right here. Could we factor out a GCF to use an easier method? You may have started to notice that your numbers get really big. Like 72 is a big number. If I try and deal with this one, let's see, 3 times 126, that's going to give me 378. That's a huge list. I don't have time to make up a huge list and go through every single factor. Can I divide 378 by 1, by 2, by 3, by 4, by 5, all the way down to however big that table is? And so there might be an easier way. So just like that 2 that was floating around this one, what we'll notice is that 12, 22, and 6 all can be divided by 2. So can we pull a GCF out of these to make our lists a little smaller? Well, give it a shot. If I divided 2 out of this one, that would mean that I would have an x squared plus 8x plus 15. Well, I was looking at 60. Now, if I just factor this piece right here, I'm only dealing with a list of 15. And I'm not actually going to factor that right now. But is that a smaller list? Yes. So 60 was reduced to 15. That's a much smaller list. I could do this one. I could pull out a 4. In this case, that would leave me an x squared minus 8x. Oh, that's almost the same problem. So if I factor this one to whatever it works out to be, with a 4 on the outside, let's see, 60 times 4 on my list of 240 went down to 15. Again, we greatly reduced the size of our list. So no matter what number we pull out, positive or negative, all these are divisible by -2, all these divisible by -3, we notice that it just makes our lives a heck of a lot easier. this is going to give us x squared plus 23x plus 42, which whatever that factors down into, we know that 2 times 84, our list of 168 just got reduced down to 42. Not as impressive, but still, that's pretty dang impressive. Here, x squared plus 13x plus 42, well, it's almost the same style problem. Here, our 378 got reduced down to 42. That is an impressive skill. So we're going to go over that in a future video. There you go.